the definition for perpendicular? We should have looked them up. Perpendicular. We got
an angle of 90 degrees to a given line, plane, or surface.
Did you guys hear him?
No.
All right, one more time, sorry.
An angle of 90 degrees to a given line, plane, or surface.
An angle of 90 degrees. Okay, what would that look like? So if you're filling in that other section of your vocab, what would your picture look like?
90 degrees on.
What is that? Like this?
Yeah.
Okay, so it would look like a cross, an intersection, 90 degrees. So if you were to write a non-example, what could you give me as a non-example of perpendicular lines? Parallel lines. Good. Are there any questions about the definition of perpendicular? No. Okay, you guys know what station you're working on? I need to see a couple people briefly before you get to work. Brandon Byron, Josh, Alexis, Tristan, Shannon, Chris, Mike, Tompkins, Dylan, and Corey. Well, now we can get to work. But the rest of you, I need an activity performance task from last cycle. You didn't turn it in.
Okay.
Performance task from last cycle.
Lesson real quick on what slope and stuff is. So you guys need to make your way that direction, please. If you haven't had it yet.
What slope is?
Since your activity concerns slope, intercept, parallel, perpendicular, we decided this was a good time to do this lesson. Of course the spark board's not going to work. Next question is, are you doing we cover slope, parallel, perpendicular, the basics. We need to understand slope, intercept, and writing those equations and lines and what they mean. So we're going to go over a few of the definitions first, and then we're going to talk about how to figure these out on a paper, and you're going to try one of each kind of example. And if you know what this is and you think you have it, don't waste time. Go ahead, write, and do one of each, and you'll just show me the answer and you'll be out of here. If you don't know what it is, this is the opportunity for you to have it reviewed or covered before you actually have to calculate it on your activity. Okay? So, we're starting with what is slope. First thing that you have to realize is that they use letters to indicate specific things in equations. The letter M is what we use to show slope, and slope is a rate of change. It's the change in y over the change in x. You might know it as rise over run. Okay? Now, what do we mean by rise over run? We're talking about what's happening on the x-axis or what's happening on the y-axis. It's how you move in a graph. So I'm going to put a little mini graph right here. Okay? All right, which axis is this? X. If I go this way, I'm going to the positive, and what am I doing this way? Negative. This is my negative axis. What's going up? Y what? Positive, so down is y negative. So when I'm talking about the slope and I say it's the rise over the run, I'm meaning how far did I move up or down over how far did I move left and right to go from one point to another point. Okay, and that's how we do it. That's the physical calculation of it. You can draw the rise over run to find it. You can also use a formula, and that formula is on your paper, y2 minus y1 over x2 minus x1. We're going to go over one of each of these and then we're going to try it. Okay? So let's start with, let me give you a line. So here's 2 points, and if I wanted to calculate the slope of that line, now, my line may not be perfect, but get ready, the line goes like this, right? To calculate the rise over run, you start at one of the points where it's crossing nicely. I tend to pick an axis. Does every line cross the axis where you can do it? No. So make sure you're just picking where they are on an actual perfect point. Otherwise you start ending up with, oh well, let's see, it's 1.3, and then it gets ugly, right? So let's start here, and I always say, because it's rise over run, we want to do the up and down part first. So my question is, to go from this point to this point, how far up or down do I have to move?
4.
So I'm going up 4, and notice I put an arrow. Why did I put that arrow?
So you're going up.
Because I'm going up, and it's going to be positive going up, right? Okay, and how far this way?
6.
6. Okay, so I went up 4, and I went to the right 6. So using rise over run, my slope is 4 over 6. And is it okay to leave it like that?
No.
Why not? It's not simplified. So Tristan, can you tell me how to simplify it?
You just divide by 2.
Good. So what is the final answer? Slope is
2/3.
2/3. So on the activity, when we ask you to draw the slope, this is what we mean. Now what if you didn't draw it and you wanted to use the formula? To use the formula, you need the actual coordinates. So somebody tell me what this coordinate is. This point.
6.
What kind of 6?
-6.
-6, comma what?
0.
0. Remembering that anytime a point lies on an axis, one of its coordinates is 0. So what's this one?
0.
0 how much?
4.
0, 4. Good. So the reason I put those up there now is because now we're going to try to use this, and I'm going to give you a little help. One of the errors that's most common here is you lose negative signs because there is a minus in the formula. So my suggestion is whenever you're going to calculate slope using the formula, do this. Now why did I do that? To separate out those negative signs. Very good. So let's plug in our points. Does it matter which point I pick as point 1 and which one I pick as point 2? No, but what does matter is this is x and this is y. So I'm going to call this one point 1, and let's call this x1 and y1. So if that's the 1, this is the 2. Now we're just simply going to plug it into the equation. What goes here?
0.
0 because it's y2, correct? So 0 goes here. So what's y1?
4.
Okay. So I put a 4 here. What's x2? And what's x1?
0.
Okay. Now, if this happened to be done in reverse and the negatives were over here, we get 2 negatives in a row, which created.
A positive.
That's why we write it like this, because students tend to lose this negative. Okay, so let's just do the math. What's 0 minus 4?
-4.
So it's -4 over, what's -6 minus 0?
-6.
So, is our final answer of 2/3 still correct?
Yes.
Yes, it does reduce to 2 over 3, and a negative over a negative is a positive. Does this sound familiar?
Yeah.
You remember seeing this one before, right? Okay, so on the front part of your paper, okay, this is the side that says find the slope. Please do problem number 1 and problem number 11 to show me that you understand how to calculate slope. If you think you have it, just ask it, I'll come and look. Okay, I need my glasses. I'll be right back. Oh, That's a really great question. Do you mind if I do it to the whole group? Okay. Shannon just had a really great question, and this is one of the problems we've been running into on Alex. And the question she asked is, well, what happens if I have a fraction, let's use our guy that we already had, that looks like this, but on the paper, they put the negative right in front of the fraction bar, and the question is, which piece does it go to? And the answer is, it doesn't matter. You can choose at that point, and here's why. Because the reason the whole thing is negative is because one was negative and one was positive, and as long as you make one of the two negative, it still works. And then I'll go to the picture to show you why. What if I went from this plane to this plane? Then this would be a negative rise, because we went down, right? And a negative run, because we went left. So would my answer still come out to my positive result? That's why that works. Okay? So it doesn't matter. If it's in the front, put it wherever you're headed. Okay? You got it done? Good? Good. You got it.
If you're reading from left to right, this would be greater.
Okay, show your equation while we take.
That's the first step. So if you do this, right, you do this. Now I'm going to show you how you do
Dylan, I need your papers.
Now the answer from the picture should have been a negative 3/1. If you don't have it negative, please look as to why. The picture's right here. Don't you have to move down and left or up and right, down and left? Oh, that's double negative. It should be up and left. You had to move up and left in your picture or down and right. And there's a negative in there when you do that. So if you had the sign wrong, pay attention to this. It doesn't matter what quadrant you're in, which is my mistake. It matters what direction you move. So if you're up here at +6, but you have to go down to +3, that's negative. You move in a negative direction, okay? Everybody that seemed to be having a little trouble with the formula, I went and I talked to you about putting in this, but I added something on the top. I added what the actual formula is, because as long as you've got the formula written there, substituting into it isn't the problem. So what was the answer to the calculated slope? Anyway, 2/15. And if you didn't get 2/15, I want you to stay back and let me work with you one-on-one. We're going to flip to the second side and do the y equals mx plus b part, and then you're out of here. Okay? So, the formula for slope is the y2 minus y1. The equation of a line is y equals mx plus b. Does everybody remember that equation? You've seen it before, right? And here's the key. This is where you guys will make mistakes a lot. This is your slope. This is your y-intercept. The slope is the number in front of x. So does x come with it? No, just the number. Slope is a number. So this is slope. And this is your y-intercept. And what's a y-intercept? Anybody? Where it crosses the y-axis. Okay? So if they give you the slope and they give you an intercept, can you just plug right into the equation? Yes. Okay? If they give you the equation, can you tell me the slope and the intercept? Yes, just by looking at it. So, the examples up at the top of the page, some of them are ready to tell me what's the slope and what's the intercept, and some are not. Which ones are ready?
Y equals negative.
Y equals something. So if the equation says y equals, you can tell me what the slope and the intercept is just by looking at it. So let's look at problem number 1. Problem number 1 says y equals what?
Negative 5 over 3 x.
Negative 5 over 3x. So what is the slope?
Negative 5 over 3.
Negative 5 over 3. So m is negative 5 over 3. We know it. What's the intercept? They didn't give us one. So if it's not there, what number is it?
0.
0. So don't be confused or alarmed when you see equations that are missing parts. It's just telling you which part is missing when it's not. If you're missing the x part, the slope has to be 0. Okay? If you're missing the y part, then you have a special kind of line which you'll discover on your own. But if you're missing the intercept, it's not really missing. It means the intercept is 0. Okay? If it's not in y equals, in other words, if it looks like this, 2x minus 4y equals 15. What do you have to do to be able to tell me the slope and the intercept?
Get the Y alone.
Get the y alone. So what I want you to do is go to problem number 3, and that's what I want you to do. Solve for y, and tell me what's the slope and what's the intercept. If you're getting stuck on how to solve for y, raise your hand, I'll come over, I'll one-on-one with you. So, when there are 2 variables in a problem, we don't let it bother us because you're not really solving it, you're just rearranging. So we want to rearrange so that this is by itself. So I need to move this piece. So how would I move positive 7x to the other side of the equation? Opposite operation, like everything else we've done in algebra. So I'm going to minus 7x from both sides. So what happens here? Plus 7x minus 7x. What happens to them? They cancel. Okay, so what's left on this side? Write it down. Equals, now write the x term first. So what goes first on this side? X first. Negative. Okay. Just write the x term. Nope. What's the x term? No. The whole term. Oh, okay, good. All right, the whole term means, when we talk about a term, we mean the number, the letter, and the sign, all together. So what's the whole x term? The number, the letter, good, negative 7x. Now, why did I make you write that and not put it with this? Are these two capable of being added together? No, and they're not, because this is an x and that doesn't have an x, so they're not like terms. So it's just negative 7x minus 8. We're almost done, but we want this alone. So what we gotta do is go back to this. It's not n. That's another thing. Okay, so let's make sure you understand, right? Remember, it's opposite operation. What operation takes place between q and y? So how do you get rid of something that's the opposite of multiplication? Divide. So you're going to divide that, this, and this, all the pieces, by that number, and actually take the sign the other way. Got it? So now what happens here? Y equals, okay. Now, is it okay to have a fraction for slope? Yes. So you're going to put 7 over 2x. No, because why did I say get rid of the negative? 2 negatives and they make a positive. So are we going to get rid of the negative here too? Because 2 negatives make a, so write it, plus, and now do the math. What's 8 times 2? There you go. Now my question is, do you have y equals? Once you have that, this is the slope, and that's the intercept.
Negative
Got it?
9, the absolute value would still be equal to 9.
Yeah, my bad.
Okay, should have gotten y
Okay,
equals
so now what we need to do is graph both of these on a line.
okay,
Okay. So we would graph W is greater than or equal to and less.
that's correct.
And when you're graphing, keep in mind that if you have a greater than or equal to or a less than or equal to sign, you have a closed circle, right? And if you have just the greater than or less than, it's an open circle.
Okay, so now
So first you would want to look to see where your numbers are. So negative 11, I mean positive 11, excuse me. We're going to have a closed circle at positive 11.
Yep.
And then we're going to shade wherever it's greater than that. So then that's what they already did. And then you look here, negative 7. I need a closed circle, and it needs to be less than. So then we would just correct them both.
Yeah, by moving it to the denominator, it gets rid of that negative, because we don't really want negative exponents. We want to try to get rid of as many negatives as we can. And you had your negative in front here. That was correct. Not sure why you took that. Yeah, no, you had the negative in front. You got to put the negative back in. You had it there, and then you took it out.
Make your equation into 2, our absolute value signs go away. Because once you take the absolute value sign, we're knowing that if we break that into the 2, it'll give us the answer. Does that make sense?
Yeah, I got you.
Okay.
So then you add 4.
Yep.
So 15 on the line, yeah. Not capital 1, 15. I can't do, no. No, that's probably why I was wrong this last.
So now what does this mean? What kind of circle do we need? At what number? Alright, let's plot one. Now which way should our arrow go? Because B is less than.
Going to the left.
Okay? Okay, so what's the other one we have? Open or closed?
Open.
At what number?
Negative 2.
Okay, so put that where
First, you gotta highlight those lines, and then we'll get on to this part. You can do colors, or you can use it. Do you need straight or are you happy?
No.
You can use this as ideas.
And he wants 5 shelves. So
Oh, so
here,
he needs 5 of these?
this,
This is.
how many shelves do we have? This is 3 shelf bookshelf.
Yeah.
We need one with 5. So this is just giving you a diagram what a 3 bookshelf looks like. Now you need to make one that has 5 shelves.
So we
So
need 2
how
more.
many? 2 more.
5.
Yeah.
So you need 5, right? So you don't already have this. The only thing you already have is your bricks. So how many bricks does he need?
18.
So how many does he need for this one? If you need to draw yourself an extra picture on the side,
Just need. We need 30.
did you count both sides? I didn't count, okay, so.
Well, that's 18 on both sides, but doesn't he need like another whole set?
How many more?
Oh,
3, 6,
12.
9. How many?
I said 30. He's gonna need 30.
So how many do you have here?
18.
3,
Oh yeah, with 3, but both sides is 18.
3, and 3.
Mm-hmm.
And then how many more shelves do we need? 2 more. 3 more. And 3 more. So we got 3, 6, 9, 12, 13, 14, 15.
15 times 2 is 30.
There you go. I thought you said it was 18 on the side.
No, like
Yeah,
one,
like
for
one
one,
whole side,
like one side. Yeah.
So where are your 1 inches on your picture?
Right here.
Right there. So this is 1, this is 1, this is 1, and then you're adding 2 more on top.
So there's 5. So
Yeah.
5 inches already, then these are each 3.
Yeah?
So we.
Maybe 54, 53? I think I did that too quick. I think it's 54.
Jay, what do you think, Tristan?
I think.
So you think 53, you think 54.
Not 54. I just counted too fast.
4, 5,
So how many
So
makes
we're gonna
one shelf?
5.
9.
3, 6, 9, plus
1.
1,
10.
10. So how many more do we have to add for this one?
That'd be 9.
Oh, we need 50. If it's by 10.
Do you agree, Mike?
10, 20, yeah, 50.
What's this one?
I get the same answer, don't I? What's the answer to the slope? If I
Don't flip this one, you flip the one with the bar.
Gotcha.
And it doesn't matter.
Always the denominator.
So does that
Well,
clear up a
this
little
is
more?
divided by that.
With
And
where
then
you
you
would
just,
slope?
then
Okay,
you
so
notice
that's
to
one.
remember their negatives.
That's how we find slope. The second thing we have to talk about is what's an intercept.
Yeah, I just want to make sure you write down.
Yeah.
Don't forget to bring your subtraction sign down. I think you don't need to, no, not anymore.
Trying to start with 5. Trying to find the easiest one to find.
I'd say 48, yeah.
48 would be the triangle. So, and that's the
Number A. No, C. So this would just be the wood. Is that all you do? Just write wood?
You write the description number for whichever graph it is. So if we're doing graph C, which description deals with the length of the wood?
48.
Yeah, so that would be for description graph C, that would be the graph. So that would be the equation. So you put y equals 48.
we're doing that's the description.
We have to then find which description up here has to deal with the width of the wood or the length of the wood.
Yeah, the width of the bookcase.
Exactly.
The
So
description for it?
So for that description, no matter how many shelves tall your bookcase is, it's always going to be the same width. So that's why the equation is constant. It's always going to be 48 inches, regardless of how tall it is.
And 2.5 is the cost of wood, so that'd just be description 1.
And then you got to find. So you know description 1 is cost, but then we have to find which equation represents the ground.
I would say graph B.
And then it's 2.5 x. And the x is kind of lost on the piece of paper. For description 1. So we want to make sure that our equation matches the line we picked. So we have B up here. So it's kind of hard to find. Oh, here we go. So when you have, how I like to double check it
Oh, no,
is,
but it isn't D.
yeah, because if you were to plug in x is 5 into this equation,
That'd be way too much.
it would be way,
Yeah.
exactly, it would be way too
Something equals 53. And I want to solve for the something. I would have to subtract u from each side, and I get 53 minus u. Does that make sense?
Yeah.
That's all right.
7/10 over 8/6.
Now we're gonna talk about.
Divided by 8/6. Is that right? Wrote that out. And then remember the rule was we flip the divisor and multiply. So I flipped this.
Yeah, flipped it upside down.
Yep, and then I multiply across the top of the number, and then we got, we carried, kept our negative sign, we got negative 48 over 8 here, and then we
Then we simplify.
Simplify.
Okay.
Okay? So, for 1 hour, you said 60. For 2 hours, you said 120. For 3 hours, okay. Now we're going to talk about how we get that, because our next question is what's on the screen. H hours. So, how did you get 2 hours? What did you do? You just told me a minute ago.
Yeah, I don't know what you did though.
You said the word multiply.
Oh, yeah.
What did you multiply?
The hour, 5 minutes.
The hours, the number of hours, times how many minutes. So then how did you get this one? Did you do something similar?
Added?
So think similar to this. You added another 60, right?
Yeah.
Okay, so think in terms of multiplication, what did you do?
Times again.
Times what? By what?
3 by 180.
Not 3 by 180,
No, 3 by 60.
3 by 60. So now we're going to write to the farther concept. I don't know how many hours I'm asking you about. How, in terms of the multiplication, can I find out? So think about what we already have and the pattern we just made. Did we kind of make a pattern here?
Yeah.
So what is this number in the pattern? Where did this number come from? Look at
The
our
hours.
chart. The hours. So now that my hours are H, could I use that and apply that to write myself an expression for this?
Some people are writing 2 because they thought like, oh, we're starting with this. So since we know we need 5 planks of wood and they cost $2.50 each.
That extra minute.
Yeah. So the whole bookshelf will cost $12.50. Oh yeah, this is it's kind of like let's try to find which graphs make the most sense. And when you're looking at y equals 48, 10x, 6x, 2.5x, these numbers directly from this up here. We have the 2.5x. The cost of wood is $2.50. The length of the wood is 48 inches. And one of our lines is 48. One of our lines is 2.5. So these all kind of go together. Each shelf has 6 bricks total. One of our equations is 6x. So the goal is to read the descriptions, see which equation would fit with that, and then identify which equation is correct. So like straight across, some people were connecting their lines so they could see it a little bit better. But when I was doing this, my thought process was to let's pick the easiest line to keep it for. So if we're looking at this, which do you think would be the easiest one? Exactly, that horizontal line.
you can self-grade yourself before you turn it in. I wanted to give you an example on this overhead. Okay, I took that section B, understanding slope and intercept. I drew my lines up above, and I wrote down my part in there. I want to know what you would give it as a grade, okay? The directions were for you to highlight 3 different lines that have different slopes, draw the slope on the paper, tell me and fill out the chart with the slope, y-intercept, and equation of the 3 lines you drew, okay? So looking at this, 25 points are allotted to this section. How many points would you give me on this section? Or if this was your paper, how many points would you give yourself? Okay, go through the rubric. Did I draw 3 lines and highlighted them with different slopes?
No.
Yes? Are they different slopes? That's something you want to think about when you're looking to make sure if you did this correctly. Next one, list/draw correct slopes. Did I draw my slopes? What do you think?
People who are just at the mini lesson, how do you draw a slope?
Everybody should have now been in that mini lesson. So I see hands going like this. So yes, I did not draw slope. If I was to draw it, I would have did my over 1, up 1, right? I would have made a triangle to show my rise and my run for these slopes. I did not. So that would be minus 3 points because I didn't draw it. Did I list my slopes? Yes. Did I list all of my y-intercepts? All of them? I left part of my paper blank. So I should be deducting points, and you should be looking at that type of things too when you're self-grading. Because when I'm grading myself and I see that I left part of it blank, that's the key to go back and try to fix those errors or those things you left blank before you turn it into me. So if you're turning me in this amount of work, I can tell you that that right there is only worth 12 out of 25 points. Okay? I'll see you tomorrow.
Ms. Proto, can you help us out and explain the difference in the math lab this year with mastery-based learning compared to a traditional math classroom from a few years ago?
Okay, sure. In the last few years, I personally have tried to introduce stations into my classroom. But the biggest change had to be for the teacher to get away from those, I'm the star of the show, I'm going to teach you this lesson, everybody's going to write it down, and everybody's going to do an assignment and come back the next day and maybe we'll answer some questions. The idea behind mastery-based learning is every kid is met at their own level. So what happens is instead of 20% of the kids having no idea what I was talking about and 20% of the kids being completely bored, and then maybe the ones in the middle would be okay. We've moved to a mastery attitude, which is you have to understand it to move on to the next thing. And what that has created is every student working at their own level, at their own pace. And the difference in the understanding level for the student is huge. There's honest to goodness, real mathematical learning happening, and mathematics that they'll learning that they'll retain. That's probably the biggest difference. The teacher's no longer the star, the students are.
Great, thank you.
Okay.
Thanks for meeting with us, Mr. Roberts-Sangillo. When we look at the math lab structure, it's now 2 rooms with an open model. Can you tell us a little bit how that has worked with another teacher compared to a few years ago when you kind of taught in isolation? And also, how does it work for the students having a double room with multiple teachers?
I think at first it was hard for them to get used to just being a big open environment, but moving into it, I think they really enjoy it. They have multiple people that they can talk to. If they don't want to work with me one day and they want to work with her, or the next they can either or change. So there's always one person who can do the mini lessons, one person who can do one-on-one. So it kind of has that role where I'm lost for words. They can ask who they want when, you know,
Right.
it gives us both the opportunity to be able to help. So I think more help is actually given with 2 people in the classroom rather than 1, even though we have double the students. And as far as collaboration goes, I mean, I think we work really well together. Being able to bounce ideas back, each adding our input, I think we get a more richer lesson with a lot more rigor to it, rather than just on your own having to come up with it. It helps that way where we both bounce the ideas.
And for the most part, your lesson plans are identical because you're planning together, so you've
They
reduced the workload as a teacher because you're collaborating.
Yeah, we both do plan directly together, so they are identical. So we plan the mini lessons, we have the one-on-one, we have the activities and the performance tasks. So while one's giving a mini lesson, the other person is still there for all the individual questions on the activity and the performance task, and one-on-one help because questions always come up in the middle.
Great. One last question. I noticed in the center of the room you have a help station.
Yeah.
How does that work?
When a student is having trouble when they're working on the Alex computer, they print out their Alex explanation sheet, because on Alex it has that little button, it'll hit explain. They bring it over to us, and that's when we do one-on-one instruction with them. We'll sit down at the table and go over just one-on-one what they're working on, giving different strategies, maybe doing extra problems that we make up, along with giving them graphic organizers to help them through it for later problems. We also pull kids via our exit tickets, depending if they say they need help on a certain thing, we'll pull them the next day and call them to the help desk to go over one-on-one.
Great. So one nice thing about the help desk is, number one, they have to reach out to the Alex program. You use the help feature, see if they can figure it out, and then if they can't, they always have an adult that will support them.
Yes,
Excellent.
And if more than one kid has the same thing, we sometimes pull 2 at a time. And that's when the graphic organizers come in big too, so they can bring it home and use it as a resource for later.
Thank you.